Okay, so to find x here, first thing we're going to do is we're going to find the area using the 12 millimeters. 12 is what dimension? The side. So what we refer to as S. So what's the formula to find the area from the side? 4.8275 times S squared. So this will be times 12 squared. So I'm not even going to try to do that in my head. So we get 695.16. And of course that's in millimeters, so this is millimeters squared. That's the area. Now how are we going to use that to find x? Well, x is what dimension? D, the diagonal. The area from the diagonal is 0.7071 times d squared. If that equals the 695.16, kind of like we did when we were dealing with circles, if we were given the area and you had to find the radius, we work backwards. So if we knew the diagonal, we would square it and then multiply it by 0.7071. To go the other way, we first divide by 0.7071. So we're going to divide this by 0.7071. To get 983.11, and then square root. Now on the calculator, so that I don't have to write this down and punch it back in, because that's going to be rounding it off if I do that, I'm just going to do second square root and then second answer. That's telling the calculator to use the previous answer. 31.35. What's that? That is from the formula.
Alright, so you always use that number.
Yep, if you have the diagonal, you use 0.7071. Now, of course, the one that we didn't use is the flat. Flat would go perpendicular to opposite sides. And, of course, the area based off the flat would be 0.8284 times the flat dimension squared. Why would you ever want to do an exercise like this? Well, because you have a sadistic math teacher that forced you to, for one. Two, if you had a piece of round stock, or if all you had was round stock, and you needed to make a piece of octagon stock out of it, or create an octagon piece out of it that had a side of 12 millimeters, a regular octagon with a side of 12 millimeters. What this is telling us is the minimum diameter of that round stock is 31.35 millimeters. So probably a 32 millimeter piece of round stock is what you're going to start out with to create that piece of octagon material. Does that make sense? Because X, or D, the diagonal, would be the diameter of that circle, of the smallest circle that would contain that octagon. It's called a circumscribed circle. What do you think? Good stuff? Okay. Okay, so we had a packet, page 170 in your packet. 1 through 5. I only had 5 problems. I must not have been feeling well.
I know, huh? Well, I figured quiz coming in, it's not bad for it.
Okay. Number 1, you get an area of 159.1 square feet. Number 2, 4.8275 square feet. Number 3, 13.98 feet. Had to work backwards on that one. Number 4, also working backwards, 9.95 feet. And number 5 is actually similar to the one we just did, 84.9 feet. Well, that would be the perimeter, so the length of the side would be, of course, 1/8 of that, like 10.5 feet, 10.49 feet, whatever. Any questions? Okay. So we're doing okay with octagons? Like I said, those are specialized formulas, but octagons do come up enough that it's useful. And next semester when we do trig, you guys will all know where those formulas came from. We'll be able to derive them. Something to look forward to, huh? Contain your excitement. It's okay. No, just kidding. I want you to find the area of this for me. So obviously we're going to have to either divide this up somehow or expand it out and subtract off. Either way will work. How did you guys want to approach it? Do you want to divide it up? Do you want to expand it out and subtract back down? Your call. You expand. You divide it? Well, let's do it each way and see if we get the same answer. How's that sound? If I expand it, what's this overall dimension out here? 32 plus 6 is 38. So we have 38 inches by 40 inches, which is what? 1,520 square inches. Then we have to subtract out this 6 by 8, which is 48. And we have to subtract out, this one's 14 by what? 20. This comes out to be 20 inches. Does everybody get that to be 20 inches? Because you got 40 across here. 8 and 12 makes 20, so another 20 adds up to 40. So that is 20 inches. So it's 14 by 20, or 280 square inches. So that is what, 328, 1192. Is that what you come up with? If we were to cut it down and expand it out, I'd probably cut it across here. And probably this way, I don't know. What's this dimension here? 38 minus 14 is going to be 24. Is there anybody that's struggling finding those missing dimensions like the 24 and the 20? You are? Okay. Because that is big. If you can't do that, we can't really do much more. So the key is, this missing dimension here is a vertical dimension. So we have to look at all other vertical dimensions. Horizontal dimensions mean nothing to us right now. I'll get rid of some of my mess here. So all of the vertical dimensions would be this one, and this one. So you think of that length as being a distance. If I know the distance from here to here, well, that's the same as that length. Well, to get to that distance, I have to find another way to get there other than this dimension that I'm looking for. So I have to go to the other side of the object right here. This takes me down, of course, 32 to right here. So I'm going to label its position at 32 because it's 32 away. This is horizontal. Horizontal does not change my vertical position at all. So everywhere along this line here, I'm 32 units away from this line up here. So 32, right here even, I'm still 32 units away, right? Does that make sense? But now I drop down 6 more. So 32 plus 6 means here I am now at 38 units away. Everywhere along this line, I'm 38 units away. So over here, I'm still 38 units away. And now I'm vertical again, that's 14, but now I'm not adding, I'm subtracting. I'm moving back closer. So 38 minus 14 is 24. So here I'm 24 units away. And this whole line is 24 units away, so it gives me 24. Does that make more sense? So we've got the 24 there. So we've divided it up. This first piece here is 40 by 24. Which is what, 960 square inches? And then we've got this piece here, which is 12 by 14. Oh, which is what, 168 square inches? And then finally this one here, which is 8 by 8. This is 14, subtract 6. This has to be 8 here. So 8 by 8 is 64, which, surprise, surprise, adds up to 1192. How many of you had 1192? Okay. How many have no idea how we got 1192?
For some reason I have problems with one. That was easy because they're all equal. And you got one that comes out a little farther.
Oh, sure.
We're going to look at it forever. I can't figure out that.
You mean one like this? Well, ironic that you, what's that? Yeah, I would say ironic that you would say that because let's do it. What else you got to do this morning? You could be napping, but would you be having this much fun napping? Wow, I'm hurt. I'm going to have to go home and cry a little bit now. You guys are heartless. Just plain heartless. Find the perimeter and the area.
Perimeter?
Yeah. Of course, the first thing we need to do is find missing dimensions. Let's do that. What's this dimension here have to be? Well, we've got 52 across here, so we have to have 52 across these horizontal dimensions, right? So 8 and 10 is 18, 30. That has to be 22, right? Yes, not drawn to scale. Not even close. You are correct, sir. This one. So this is 60. So I'm going to back up 12, which will put this at 48. Everybody follow that? 48. Plus 4 puts this at 52. Back 10 puts this at 42. So that's 42 inches. Now I'm going to pause it again, and I'll let you guys go from there. Obviously, perimeter, you're just going to add them all up. So for perimeter, what do you get? 220, sound right? I've got 52 plus 42 plus 22 plus 10 plus 12 plus 4 plus 10 plus 12 plus 8 plus 60, right? Which adds up to what? 94, 116, 126, 138, 142, 152, 164, 172, 232. Do you guys have areas yet? Or need a couple minutes? Need a minute? Okay, we'll give you a minute. For area, I'm just throwing this out there as a possibility. I would expand it out. You could chop it up if you wanted to. Do the 60 by 52, which is going to be 3,120. Then I'm going to subtract out. This one's going to be 12 by 10. which is 120. This one here is going to be 12 minus 4 is going to be 8, which will make it 96. And this one's going to be 22 by 10 plus 8 is 18. Which is what? 396? So what? We subtract those all out, we get what? 2604? 2608? Or 2508? Is that what you guys got? Okay. Any questions on that? Now, hopefully you would have came up with that same area if you chopped it. Well, you should come up with that same area if you chopped it up too. It's just this one's a tough one to chop up. I'd cut it across here and then like that. Maybe, I don't know. Okay. Anyway, let's try this one. Perimeter and area again. For perimeter, we've got 30, 12, and of course another 30. But we also have then this half circle. To find that half circle would be the circumference of the whole circle, pi times diameter. What's the diameter? 12. And then, of course, divided by 2 gives only half a circle. Which would give us 18.84. So that's going to add up to give us, what, 72, 80, 90.84 inches is our perimeter. How many of you got that? Okay. Area. We have the rectangle, which is 30 inches by 12 inches. 360 square inches. Then the half circle is going to be pi times 6 squared. Where did the 6 come from? Half the 12. It's the radius. Pi times radius squared for area. Then, of course, divided by 2. $56.52. So that will add up to 416.52 square inches. Well, since we're on a roll, sure. That's a, there you go. Find the area of this part. Find then the outside perimeter. And the inside perimeter as well. Okay. For area, sometimes it's not about just chopping things apart. Sometimes you rearrange them and put them back together. Like if I cut this off like this, and I put those two pieces together, I get a donut ring like this. What is the radius of the big circle? Well, the diameter all across here would be 10 plus 16 plus 10, which is 36, right? So half that would be 18. So that large circle is going to have an area of pi times 18 squared. Otherwise known as 1017.36. Now again, you may be off by some decimal places if you use the pi key. That's no big deal. What's the radius of the small one here? That should be 8 feet, right? Half of the 16, or 18 minus 10 if you want to look at it that way. That area then is going to be pi times 8 squared, or about 201, 200.96. We subtract, we get 816.4. .40. So that's part of the area. That's these two parts. Now then this, how far is it from here to here? Well, this is 18, that's the radius. This is 18, that's the radius. So 80 minus 36 makes this 44 feet. Did I find out where the 44, see where that 44 came from? From here to here is one radius. From here to here is another radius. So that's 44 by 10, or 440. And of course, the other side's the same. So that is going to be, what, 1696.40 square feet. The outside perimeter. You got 44 and 44. Plus, again, I'm going to combine this piece and this piece to be just the circumference of the big circle. That's just going to be pi times 36. Otherwise known as 113.04. So you add that together, we get 201.04 feet is the outside perimeter. Well, inside perimeter is 44 and 44 again. The difference is it's going to be this small circle. So it's this one here. So it's 16 times pi, or pi times 16, which is 50.24. So 88 plus 50.24 is 138.24 feet is the inside perimeter. What do you think? I'm going to leave you with one to think about for tomorrow. And yes, I'm going to still give you homework. Don't worry.
Go, guys.
Well, yesterday was 5 questions. Find the area of this shaded part here, assuming that I stayed within the lines. So that's 20 inches. There. And there's going to be a new packet I'm going to hand to you. And in this new packet, it's going to be pages 174 through 177. We may have to discuss this a little bit tomorrow. No big deal. So I'm going to hand out that packet right now. The problem that's up there, by the way, if you come in tomorrow with the correct answer, I'll give you a couple bonus points on our next quiz.
20.
Yeah. Something's slightly off there. Let me think for a second. I gotta remember. Actually, no, you're right.
Well,
Show me tomorrow. Yeah, you're. The perimeter is actually easy.
What about the perimeter too?
Yeah, you should find the perimeter too. But the perimeter is pretty easy. If you found the area, you know how to find the perimeter.
just the
I thought you
shaded,
just wanted the shaded area.
just the shaded area.
No, I think that's all I had said was the shaded area. But while you're at it, find the perimeter just as well. It won't hurt.
Just the shaded area.
I'm just around the shaded part.
Obviously, it's too easy for him.
You guys haven't had a quiz for a while. Take that for what it's worth.
Right? Let's have a Friday, we need.
But all of this is Wednesday of a new week already. Okay, we'll see you guys tomorrow.
Yeah.